Hello, so in this video I'm going to give a quick overview of the structure of our code and how it works a little bit, and then I'll demonstrate the functionality of our game. So to start off with, we'll look at the structure of the code. So we're here in the main file. The main file is the entry point of our game, which has this conditional, which just asks us if we want to enter test mode or if we want to enter a normal mode. The test mode, if we choose to enter that, we'll open a file chooser to run a test text file. But assuming that we run the game normally, the first thing that happens is we're prompted for how many games we want to play in our match. We receive the players and the game is initialized. The input is received by the command class, so that's probably the first big one to look at. The bulk of what happens here takes place in this switch statement, accept command, which just uses the switch statement to do whatever needs to be done to process each of the possible commands. Mainly this switch case just takes a command and runs some method in the match class, or uses some other utility method, like we have get integer and get strings down here, and this choose option. These are really just sort of wrapper methods to parse our input and do what needs to be done with it within this accept command method. It'll do things like make changes to the match or to the game according to what the player wants to do. So the next thing to look at is probably the match itself. And the match is just a wrapper around the game. So a match has many games determined by the number that the user inputs when prompted for how many games they want to play in their match. The match instantiates the players. This add players, which is received from the user. It sets the current player based on a dice roll. This set initial player. In terms of the game itself, the game class is where a lot of the heavy lifting of the program takes place. It determines the legality of moves. This one here is legal move. It lists the available valid moves. If you say get all available valid moves. It processes the player's move choice. You find out which pieces are movable. You have to actually have this inner class move to represent the moves, so a from and a to point. Our standard getter and setter methods for this as well. We can process the possible moves based on the dice rolls to let the player, do what they want to do based on whatever roll they had to determine what moves they're allowed to make. That's pretty much it for the game class. The next thing up, I suppose, we'll look at the board itself. As the name suggests, that's what handles the board creation. So a board has many points, and the point is the data structure that we use to represent the pieces on a given point. So it's a wrapper around a simple stack, pretty much. I look at the point actually. So the point is pretty much just a stack. Keeps track of the column, the row, the black and white positions. So we use these to represent the points inside the board. The board has many points. Obviously the point class then is going to have methods for getting the point positions, adding pieces, removing pieces, determining which player is on top of a given point, as we'd expect, I suppose. The game itself, or the board itself, I should say, sorry, is going to generate the board, construct all the points, define the rows and columns for the start positions. We have one for creating the printout of the terminal. And I suppose we could move on to some of the other classes then, considering we're short for time. The other classes probably are less significant in terms of functionality. I guess they're sort of utilities. The other classes, we have the cube, the die, the player, and the log to look at. So the cube just represents the doubling cube to control the multiples of a player's pip score which they incur when they use the doubling cube. That's pretty much it. All it serves to do is to double the stakes. The die itself, the die again obviously represents our set of dice, so it just uses two random numbers to decide the dice roll, value 1, value 2. This is what the role does. And this one follows a singleton pattern. So we have this get instance. So there should only ever be a single instance of the dice in the game. And the log actually follows the same pattern because, again, there should only ever be one instance of the log, which, the same instance of a log is going to follow across all the different games that we have in a match. And the player finally, as you'd expect, the player represents the player objects in the game, which includes all the information about the player, the ability to move pieces, determine if a player has won or if a player is off the board, if a player is on the bar. It also determines the player's score using this get game score. And that's pretty much it. We didn't have much time to go through the structure, but next up we'll just show you the functionality of the game and what it can actually do. Okay, so just to demonstrate that actually playing the game, I've started a new game. When you start, you get two options. Do you want to enter test mode or do you want to begin a normal game? I'll enter a normal game. Number of matches you want to play, or sorry, number of games in the match, say 2. Confirm, enter a player. Confirm both times. You could begin the game or quit then. Let's say quit just to show it. It says goodbye and it uses system.exit to exit the game. I'll play again. Begin the game. It says we're playing game number 1 of 2. Jake rolled a 6, Richard rolled a 1, so Jake goes first based on the higher number. Let's say the pip score. They both start off with 167. If I say hint, prints out all the possible moves. I just say move. Here's all our possible moves we can make. And it just keeps going until the user runs out of moves they can make. Let's just try roll this time. Oh, sorry. Okay, so Richard rolled 5 and 4. Here are his optional moves. Say 1 or 2. And we can see our pieces moving around on the board as we make these moves. Let's try roll again. And of course, these games can go on for a very long time, so I won't actually run the game to completion. Let's just say next. Okay, now we're playing game number 2 of 2 in the match, and it starts the whole match again. And that's pretty much it, I think, for what I want to demonstrate in terms of the actual gameplay. Obviously, we could keep going, and this would run the match to completion. And one player would win the game in the end. Depending on the number of games you have in the match, it increment the matches going forward. And the scores can then persist across the matches, and the players persist across the matches, as you've seen. So I think hopefully that was enough to demonstrate the functionality of the game. Thank you for watching. And now Richard will take over to demonstrate our testing approach.
So we've relied pretty heavily on unit tests in our approach. We tried to think through for all of our main methods what are the various different scenarios that we might throw, and then we mapped these out in an Excel, just kind of setting out what we needed to do, and then we created individual unit tests for all these different scenarios. Interestingly enough, it was the point objects that had the most. So you can see here, we just kind of set it up and we've commented back what's happening in each of the unit tests and what we expect to happen. There's a couple of methods where we haven't done tests. That's either because a method is just a wrapper from one class into another, or a method is just kind of a broken out sub procedure within another larger method. You can see here we've got plenty of these that are all heavily commented. I think the only 2 significant methods in it that we haven't unit tested are the main method in the main class and in match the play method, because that's effectively the game. The other thing that we did was there were a couple of times where during debugging we ran into issues, so we added those scenarios to the tests that we did. So as you can see, there's a bunch of test units here, and if I run them, 114 tests, 114 passed.